Greetings and hello everyone. Today we're going to be looking at piecewise functions. So a piecewise function has a graph that is created by many pieces. So this is smaller graphs. So let's see what that looks like. Let's take a look at example 1. And the way that we're going to solve these is we're going to create a table. Normally the way we graph is we graph through slope-intercept form. We find what the slope is, we find what the intercept is, and we go from there. But because piecewise is a collection of a bunch of different graphs, we have the graph of 2x plus 4, and we also have the graph of negative x plus 3. So that's two different things that we're graphing. And because of that, that's why we're going to create a table. So let's start off with f of x equals 2x plus 4. Remember, f of x is just a fancy way of saying y. And we're going to graph this if the values of x are less than or equal to 1. So for our table, we would have some x values that are going to be less than or equal to 1. So that's going to be like 1, 0, negative 1, negative 2, and negative 3. Then we're going to have what we're putting in that into, so that's 2x plus 4. And then lastly, we have out our y value. So if I put 1 in here, that's going to be 2 times 1 plus 4. And 2 times 1 plus 4 is 6. 0. 2 times 0 plus 4. 2 times 0 is 0. 0 plus 4 is just 4. 2 times negative 1 plus 4. 2 times negative 1 is negative 2. Negative 2 plus 4 is 2. 2 times negative 2 plus 4. So 2 times negative 2 is negative 4. Negative 4 plus a positive 4 would give you 0. And then lastly, we have 2 times negative 3 plus 4. 2 times negative 3 is negative 6. Negative 6 plus 4 is negative 2. So let's go ahead and graph this out. So I'm going to start off with a point at 1, 6. So 1, 6. 1, 2, 3, 4, 5, 6. Now you'll notice that this is greater than or equal to. So because of that, it's going to be an actual point. Then my next point is going to be at 0, 4. Then my next point is going to be at negative 1, 2. And then my next point after that is going to be at negative 2, 0. And then my last point is at negative 3, negative 2. So here are all my points for my first one. Now my second function right here is what happens when f of x equals negative x plus 3. And these values of f or x are when x is greater than 1. So we're going to build a table for this. So we have our x values, we have our function that we're plugging them into, and then we have our y values that come out. So we want values that are greater than 1. So that would be 1, 2, 3, 4, and 5. So let's put them in there. The opposite of 1 plus 3 would give you 2. The opposite of 2 plus 3 would give you 1. The opposite of 3 plus 3 would also give you 0. The opposite of 4 plus 3 would give you negative 1. And the opposite of 5 plus 3 would give you negative 2. So let's go ahead and graph this. But you'll notice that this is x is greater than 1. Since it's just greater than, this is going to be an open circle. So the point is 1, 2. So 1, 2. And as I said, that's going to be an open circle. This is where the solution actually is here. This is not where it is. It goes all the way up to here. Then it's going to continue on this graph over here. So it's 2, 1, 3, 0, 4, negative 1, and 5, negative 2. So as I was just saying, the graph over here, it's coming up. Then all of a sudden it's going to make a jump, and it's going to come down here, and then it's going to come back down. So that is the difference with piecewise function, is it's a collection of different graphs. Now we want to figure out what is the domain and what is the range. So the domain is all the x values that we could put in here. And if you notice, this just keeps going from left to right. So that would be all real numbers. So any number on our number line is going to be in this domain. What is our range? That's the highest y value that we have here. And you notice that the highest y value is going to be 6. All the y values are going to be below 6. So our range is y is less than or equal to 6. So it can be 6, but it's going to be values also less than 6. And that's the big idea with piecewise functions. So let's take a look at a different piecewise function. So I want to graph when x is greater than 2, this function. And then I want to graph when x is, so when x is less than 2, I'm going to graph this one. When x is greater than negative 2, I'm going to graph this one. So let's start off with creating a table. So we're going to create a table for this. We're going to create a table for this one, and then we're going to graph out the two. And of course, we're going to find the domain and range. That's going to be our last thing. So let's start off with the table for the first one. So we want to find the table when f of x equals negative x plus 1 if x is less than or equal to negative 2. So we have my x values. That's going to be negative 2, negative 3, negative 4, negative 5, and negative 6. We have our function that we're putting it in, negative x plus 1. And then we have our y values that come out of that. So let's put it in. The opposite of negative 2 plus 1. Well, the opposite of negative 2 is 2. 2 plus 1 is 3. Now we have the opposite of negative 3 plus 1. That's going to give you 3 plus 1, which is 4. The opposite of negative 4 plus 1. That's going to give you 4 plus 1, which is 5. The opposite of negative 5 plus 1 is going to give you 5 plus 1, which is 6. And then the opposite of negative 6 plus 1. So the opposite of negative 6 is 6. 6 plus 1 is 7. So let's graph this out. So at negative 2, we have that we are at 3. Negative 1, negative 2, 1, 2, 3. And again, it's or equal to, that's why it's going to be a closed circle. Then at negative 3, we're at 4. Then at negative 4, we're at 5. Then at negative 5, we're at 6. And then at negative 6, we're at 7. So there is my first graph. Let's take a look at the next one. So we want to graph when f of x equals negative 3x minus 2. And that's if x is greater than negative 2. So we have our x values. That's going to be negative 2, negative 1. Let's put a little more space here. Negative 1, 0, 1, and 2. And then we have what we're putting in that into, negative 3x plus 2. And then we get y values out of that. So let's start putting stuff in. So we have negative 3 times negative 2 minus 2. So negative 3 times negative 2 is 6. 6 minus 2 is 4. Negative 3 minus 1 minus 2. Negative 3 minus 1 is 3. 3 minus 2 is 1. Negative 3 times 0 minus 2. That gives me 0 minus 2, which is negative 2. Negative 3 times 1 minus 3. That gives me negative 3, not minus 3, minus 2. That gives me negative 3 minus 2, which is negative 5. And then negative 3 times 2 minus 2. That gives me negative 6 minus 2 more, which is negative 8. So this one is greater than, so it's going to be an open circle at negative 2, 4. Our next one's going to be at negative 1, 1. Then we're going to be at 0, negative 2. Then we're going to be at 1, 1, negative 5. And then the last one's going to be at 2, 8. So let's connect those up. And you notice it comes down, jumps up, and then goes back down. So what is going to be our domain and what is going to be our range? So our domain, again, from left to right, is all the x's, so all real numbers. And what is going to be our range? Well, our range really doesn't stop because it goes from the top y all the way down to the bottom y. So our range is also all real. So both of them are all real numbers. Let's take a look at our last example. If you want to try this on your own, you can go ahead and pause the video, give it a try, and then you can start the video afterwards to see how well you did. If not, you can continue along with me. So let's go ahead and take a look at the last one. So again, I have two different functions. So I'm going to say f of x equals x plus 3 if x is less than or equal to 1. And then my other one is f of x equals negative 2x if x is greater than 1. So let's list off our x's, what we're plugging it into, which is x plus 3, and then the y values that come out of that. So we have 1, 0, negative 1, negative 2, negative 3. So let's start putting them in. So I have 1 plus 3, which is 4. Then I have 0 plus 3, which is 3. Negative 1 plus 3, which is negative 2. Or not negative 2, just 2, sorry. Then I have negative 2 plus 3, which is 1. And then I have negative 3 plus 3, which is 0. So let's graph this out. So the first one's at 1, 4, 1, 4, 1, 2, 3, 4. And again, it's or equal to, so it's going to be a closed circle. Then we have 0, 3, negative 1, 2, negative 2, 1, and negative 3, 0. Let's take a look at our next one. So we have our x values. We're plugging it into the function negative 2x. It's going to give us out some y values. So we have 1, 2, 3, 4, 5. So if I plug in 1 there, that's going to give me negative 2 times 1, which is negative 2. If I plug in 2, that's going to give me negative 2 times 2, which is negative 4. If I plug in 3 into this, that's going to give me negative 2 times 3, which is negative 6. If I plug in 4, negative 2 times 4, which is negative 8. And I plug in 5, that's going to give me negative 2 times 5, which is negative 10. So let's plot this. Again, this one is, or it does not have or equal to, so it's going to be an open circle at negative 2. Then my next one's going to be at 2, negative 4. Then my next one's going to be at 3, negative 6, 4, negative 8, and 5, negative 10. So the function comes up here, then it drops down to 1, negative 2, and then it comes back down. So let's find the domain and range. So the domain is, again, all reals, because from left to right, it's all the x values we can use. And in our range, what's the top value of y? And our top value of y is 4. So it's going to be y is less than or equal to 4. So as you can see with piecewise functions, it's a collection of multiple functions. So here we're using 2. You could use 3 functions. You can use 4 functions. But it's going to be a value more than 1. Have a great day.